What is rendezvous and docking in orbital mechanics? Imagine two spacecraft in space, moving around Earth, trying to meet and connect like a cosmic handshake. That's what rendezvous and docking are all about. It's a carefully planned dance in orbit that allows two vehicles to come together safely. Rendezvous starts with one spacecraft, called the chaser, adjusting its path to catch up with the other, known as the target. The chaser must match the target's orbit, which involves changing its altitude and speed through engine burns. Since lower orbits are faster, the chaser usually begins in a slightly lower orbit to gain speed and close the gap. Then, it gradually raises its orbit to match the targets, reducing their relative speed and distance. This process can take hours or even days, depending on how far apart they start. Once they are close enough, the final step is docking. This requires very precise control because the spacecraft are moving at high speeds, but only a few centimeters per second. The goal is to align the docking ports perfectly and connect without causing damage. The docking mechanism is a specialized hardware system that locks the two vehicles together securely. It often includes electrical contacts, so they can transfer power or data once connected. Docking is used for many space missions. For example, resupply missions to the International Space Station relying on docking spacecraft to deliver supplies and crew. Spacecraft assembly in orbit also depends on docking, allowing different modules to connect and from larger structures. Satellite servicing and repair missions often involve docking to fix or refuel satellites in orbit. The entire process requires careful planning, precise calculations, and reliable hardware. It's a vital part of space operations because it enables complex missions like building space stations or transferring crew between vehicles. The maneuvers involve orbital mechanics principles, such as home and transfer orbits, to efficiently change the spacecraft's path. They also requiring small, controlled thruster burns for fine adjustments during the final approach. Understanding rendezvous and docking helps scientists and engineers design safer, more efficient space missions. It's a fascinating combination of physics, engineering, and careful timing that keeps our space activities moving smoothly.